All right, so this is the second part of the video, and now all I'm going to do is just show you several examples of how to use these properties. So hopefully you've written these properties down by now. I'll keep referencing them as I do this video, but just make sure that if any questions at all come up that you please let me know. And please don't submit the homework assignment before you feel like you fully understand what's going on, okay? So if I look at example 1 here, example 1 says that we have to expand out the logarithm. Sorry, I want to change colors. Come on. There we go. We need to expand out this logarithm. So you'll notice I have a product and I have an exponent. Well, what we need to do is we need to separate out the terms of the product first. So I'm going to do log base 3 of x plus log base 3 of y squared. That allows me to separate out the product, and remember the product property says that if you have the log of a product, then you can separate it out by adding the logs of each individual factor rather, separately. The next thing I look for in this case is I look to see if I have any exponents. Any exponents get dragged out to the front. So my final simplified version of this is log base 3 of x plus 2 times the log base 3 of y. And the goal is to make sure that your x's and your y's, or whatever your variables are, have no exponents anymore, and that each one is expressed separately. Okay? If I look at the next one, this is a product right here, so I'm going to do natural log of x plus the natural log of, I'm going to rewrite square root of y as y to the 1/2, because you should know that when you have a square root, that's an exponent of 1/2. And if that had been a cube root, it would have been 1/3, and et cetera, et cetera. Now I have this exponent, so I'm going to bring it out to the front, and so my final answer is natural log of x plus 1/2 times the natural log of y. And as you can see, your x and your y no longer have exponents or products or quotients or anything involved with them. So they're separated out. The next one is a little bit crazier. What I want you to do on this one is first square at the top and the bottom. So think of this as square root of x cubed over square root of yz. Okay? So this is going to be the same as saying x to the third to the 1/2. And this is going to be the same as saying yz to the 1/2. Which all of that is just another way of saying x to the 3/2 over y to the 1/2, z to the 1/2. Okay, so that's just me applying my power properties for exponents. All right. That's a mouthful. So let's see what's going on here. So this expression here is the same as this. So let's notice what we have. So in the numerator, I just have a variable to an exponent. So I'm just going to write this as log x to the 3/2. And then I have a division. So that means I'm going to use my quotient property, which means subtraction. And in the denominator, I've got a product. I've got y's and z's being multiplied. So what I'm going to do is in parentheses, I'm going to write this as log y to the 1/2 plus log z to the 1/2. Okay? And now the next thing that I'm going to do is write this as, so the first part was, whoops. Sorry, they all have exponents, so let's back up. Let's take those exponents and put them into the fronts of the logs. So 3/2 log x minus, and then in parentheses I'm going to have 1/2 log y plus 1/2 log z. And you'll notice that what we can do is distribute that minus sign. So I'm going to say 3/2 log x minus 1/2 log y minus 1/2 log z. That's going to be our simplified expression, okay? All right, so now what we're going to do in the next part is we're going to go the other way. So we went from taking the logarithm of a single expression and expanded it out. Now we're going to go from the expanded part and write it out as a log of a single thing. Okay, so looking at what we have here, we'll notice that we have a plus sign. So we're adding two logs that have the same base. That's important. They have to have the same base. So I can condense this down and say 6 times 8/3. Okay, so remember, if you are doing a plus sign between your logs, that means you're using the product property. You had a product of a log. Let's see, to do the math here, let's see, 6 times 8 divided by 3 is going to be 16. So this will be log base 2 of 16. That's the log of the single base, so that's what that would be, which is equivalent to 4. Okay? And it's equivalent to 4 because 2 to the 4th makes 16. Okay? So this was all numeric, so I got a numeric answer. Next one, I see at the very beginning, I've got a coefficient on the log. So I'm going to bring that, make that an exponent. So log base 3 of x to the 1/3. And I have another coefficient here that's going to go on the y. So minus log base 3 of y squared. Now the next thing to note, usually when you see x to the 1/3, we're going to think of that as the cube root of x. So I'm still just kind of cleaning up algebra here, but now I'm going to finally do the log property. So if I have a subtraction between logs that have the same base, then using the quotient property, I'm going to divide these things. And so this would be my condensed log. Okay. The next one, same idea. I've got, so notice here we've got a product, and then because of the plus sign, and then we've got a quotient because of the minus sign. So what I'm going to do is condense these with the product. So natural log of, I'm going to have x plus 2 times x. And then, because of the minus sign, I'm going to divide this by x to the 3rd. Now, honestly, you could just leave it like this. This is acceptable. Well, it would be acceptable except for one thing. Sorry, I want to go back. I noticed that I have an x on top and an x cubed on the bottom. So this x cancels with one of these. So actually, the best way to write this would be x plus 2 over x squared. Now remember, you cannot cancel these x's that are now in the problem because those x's, the x on top is an x plus 2, so it's trapped. Okay, so that's the best way to write that one. Okay, let's look at these next ones. This is just us using our inverse properties. So remember, those inverse properties said that if I have like log base a of a to an exponent, the log base a cancels with a, so I just have x. It also works if I had a to the log base a of x. A cancels with log a, and so you just get x. And if you were looking at this with common logs, you would have log, let's say it was log 10 to the x. The log without the written base cancels with the 10. Okay, and then if you were doing it the other way around, if you had 10 to the log x, this log doesn't have a subscript, so it's understood to be 10. And then finally, remember your your e numbers. So if I had like natural log of e to the x, natural log cancels with e. And if I had e to the natural log of x, e cancels with natural log. Okay, so if I look at this first one, for this one, the number 7, the first thing I would do here is you'll notice that you have an exponent that was added. So think of this as e to the natural log of x times e to the second. And why would I say that? Because when you have the same base but different exponents, you would add those exponents as we had here. Now looking at the left side, e cancels with natural log, so we just have x for that part, and it's being multiplied by the constant e squared. And we'll just leave it like that. The next one, this is basically the same thing as saying natural log of e squared to the 1/3. So I'm just rewriting what the cube root of e squared looks like. So this is the same as saying natural log of e to the 2/3 when I multiply those exponents. And natural log cancels with e, so all that's left is 2/3. Next one, this is saying natural log of e to the 3x. Natural log cancels with e, so you just have 3x. Next one, for this one, I'm going to rewrite this as 10 times log x squared because I see the 2 in front of the log x, so I'm going to go ahead and write it as such. And the 10 cancels with the log because that log doesn't have a base written with it, so your answer is just x squared. And then this one, I have to think of this as 5 squared times 5 to the log base 5 of x. 5 squared, you know, is 25. 5 to the log base 5. The log base 5 cancels with the 5, and so you just have x. So 25x would be our simplified answer. All right, see if this helped. I know this is long, watching the 15 minutes I did before, and then watching these, I guess, 12 to 13 minutes that I did now. So if that was helpful, let me know. If not, I will hold a special office hours tomorrow, meaning Friday. Same time, 10 to 11. Just feel free to pop in and I'll be there.